On the 22nd day of September in 1944, at a location called Kirkville, situated close to Cherbourg in France, military history witnessed something that would fundamentally alter the calculus of warfare. An undersea pipeline began pumping petroleum products beneath the English Channel, delivering 56,000 imperial gallons each day from England's Isle of Wight directly onto French soil. This technological achievement represented more than just an engineering triumph. For the German military establishment, which had constructed its entire defensive doctrine around the certainty that mechanized Allied operations across the Channel represented a logistical impossibility, the implications would prove psychologically devastating in ways that rivaled any battlefield defeat. The German High Command's confidence had not been based on wishful thinking or propaganda, but on hard mathematical reality drawn from their own extensive combat experience. Their calculations appeared ironclad and unassailable. Without securing a major port facility within 72 hours of any amphibious landing, Allied armoured formations would exhaust their fuel reserves and become immobilized, transforming into static defensive positions rather than offensive spearheads. This wasn't mere speculation, but careful analysis rooted in actual operational experience. During the Lightning Campaign through France in 1940, German panzer divisions had repeatedly pushed beyond their supply lines, despite operating over land with access to captured French petroleum depots and infrastructure. The 1941 invasion of the Soviet Union had seen entire mechanized corps sitting idle and vulnerable because fuel supplies couldn't keep pace with the advance, even though they were using captured Soviet stockpiles. Given these realities, how could the Allies possibly maintain sustained mechanized operations across 70 miles of hostile ocean without controlling any port facilities whatsoever? The answer represented one of the most daring engineering undertakings in human history. While German quartermasters carefully rationed every litre of fuel, calculating each kilometre of vehicle movement against tactical requirements and weighing every operation against its fuel consumption costs, Allied engineers were preparing to pump petroleum directly from English refineries through steel pipelines resting on the seafloor, creating what amounted to an invisible bridge of fuel that would sustain the largest amphibious invasion humanity had ever attempted. This operation carried the designation Pluto, standing for pipeline under the ocean. Field Marshal Erwin Rommel, whose reputation as the Desert Fox stemmed partly from his intimate understanding of fuel logistics gained through painful experience in North Africa, had personally assured the Wehrmacht High Command during a planning conference held at Berchtesgaden in May of 1944 that the Allies confronted an insurmountable logistics problem. Without port facilities, he argued, their mechanized forces would become immobilized within 4 days at most. German strategy needed only to hold the ports to guarantee Allied defeat. This assessment shaped every element of German defensive preparations. The concentration of fortifications around port cities, the positioning of strategic reserves, the allocation of precious artillery pieces, the placement of beach obstacles, all of these decisions flowed from Rommel's fundamental calculation about Allied logistics capabilities. Rommel's North African experience had taught him these lessons through bitter first-hand experience. His Africa Corps had been defeated as much by supply failures as by enemy action, with Italian merchant vessels proving unable to deliver adequate fuel across the Mediterranean, despite the relatively short distances involved. He had personally experienced the acute frustration of holding superior tactical positions that had to be abandoned for lack of fuel, of watching defeated enemy forces retreat beyond his reach because his tanks ran dry before catching them. Now he felt confident the Allies would face identical insurmountable challenges, only magnified because they had to cross the Channel while under potential German fire. What German intelligence services didn't know was that British engineers had been working on precisely this problem since April of 1942, when Lord Louis Mountbatten, serving as Chief of Combined Operations, approached Geoffrey Lloyd, the Secretary for Petroleum, with what seemed an impossible question: could pipelines actually be laid across the English Channel? The question emerged from the painful lessons of the Dieppe raid, which had demonstrated conclusively the impossibility of capturing any major port intact against determined German defenders who had months or years to prepare fortifications. The engineering challenge appeared overwhelming on every level. The English Channel presented virtually every obstacle imaginable to pipeline construction. Depths reached 600 feet in certain locations. Powerful currents possessed enough force to snap steel cables as if they were thread. The seabed varied dramatically, with rocky outcroppings capable of rupturing pipes and sandy areas that could shift unpredictably, exposing vulnerable sections. Tidal movements displaced massive volumes of water twice daily, creating tremendous lateral forces that could displace even heavily anchored structures. Weather patterns were notoriously unpredictable, with storms capable of generating waves that threatened surface vessels, much less submarine installations. Despite these formidable obstacles, Arthur Hartley of the Anglo-Iranian Oil Company, regarded as Britain's leading petroleum engineer, accepted the challenge and assembled a team that included some of the finest engineering minds in Britain. Working alongside Siemens Brothers, specialists in submarine cable technology, and experts from the National Physical Laboratory, they developed two revolutionary approaches that would permanently transform military logistics. The first system, designated HAIS after Hartley, Anglo-Iranian, and Siemens, represented a fusion of petroleum engineering and telecommunications technology. The design featured a 3-inch diameter extruded lead pipe at its core, capable of carrying various petroleum products. This central conduit was surrounded by layers of paper tape impregnated with bitumen for insulation purposes, then wrapped with steel tape for structural strength, creating something that could withstand internal pressure while remaining flexible enough to conform to irregular ocean floor topography. The outer layer consisted of galvanized steel armor wire, providing protection against external damage while allowing the cable to be handled using techniques similar to those employed with traditional submarine telegraph cables. The second system, called HAML, after the engineers Hammack and Ellis, took an entirely different approach. It employed 3-inch welded steel pipes similar to those used in Iraqi oil fields, but manufactured to exceptional tolerances that exceeded normal commercial standards. These pipes could be welded into continuous lengths and wound around enormous floating drums called conundrums, each measuring 30 feet in diameter and weighing 250 tons when fully loaded with pipe. As tugboats towed these massive drums across the channel, the pipeline would unspool naturally and sink to the ocean floor under its own considerable weight. The testing phase revealed just how enormous the challenges were. In December of 1942, HMS Holdfast laid a trial pipeline across the Bristol Channel from Swansea to Ilfracombe, covering a distance of 50 miles. The operation took place during winter storm conditions, with waves reaching 20 feet in height. Despite these brutal conditions, the pipeline was successfully laid and immediately began pumping fuel at 600 pounds per square inch of pressure, later increased to 1,500 pounds per square inch. The success was classified so highly that local fishermen who accidentally snagged the pipeline in their nets were informed they had caught a new type of German mine and should avoid that area of the channel. German intelligence had photographed these preparation activities throughout 1943 and into early 1944, but catastrophically misinterpreted what they were observing. A Luftwaffe reconnaissance report dated July 19, 1944, discovered in Wehrmacht archives after the war, identified the massive conundrums at Dungeness as probable fuel storage tanks intended for invasion craft. The enormous pumping stations, cleverly disguised as seaside cottages, ice cream shops, garages, and even a mock hotel, were dismissed in intelligence assessments as civilian structures possessing no military significance whatsoever. The German misinterpretation was understandable, given their own technological experience and capabilities. Wehrmacht fuel infrastructure remained primitive by comparison to Allied systems. German fuel was still transported primarily in 20-litre jerrycans, using the same basic design employed during the First World War. Rail transport relied on tank cars that were highly vulnerable to Allied air attacks. Pipeline technology certainly existed in Germany, but was limited to short distances over land, using rigid pipes that required extensive construction time and prepared routes. The concept of flexible pipelines that could be laid like telegraph cables exceeded German technical imagination entirely. Admiral Friedrich Rüger, Rommel's naval advisor and one of the Kriegsmarine's most experienced officers, stated definitively in a memorandum to Army Group B that laying pipelines across the Channel exceeded the technical capabilities of any nation currently in existence. The pressures involved, the seabed conditions, and the installation challenges made such an endeavour impossible, he wrote. Furthermore, German U-boat surveillance, though admittedly reduced from earlier war years, would detect any such attempt. The Allies must rely on conventional tanker delivery, which German forces could interdict using available naval assets. This confidence reflected Germany's own crippling fuel crisis, which had grown steadily worse since the launch of Operation Barbarossa against the Soviet Union in 1941. The Wehrmacht had operated under increasingly severe fuel restrictions ever since that invasion began. The 1943 bombing raids against the Romanian oil fields at Ploiești had reduced supplies by 60% practically overnight. The refinery at Ploiești alone had provided 600,000 tons annually before the bombing campaign. Afterward, it managed barely 200,000 tons despite extensive repair efforts. Synthetic fuel production from coal, despite German chemical expertise at facilities like IG Farben and others, never exceeded 124,000 barrels monthly, representing a tiny fraction of what the Wehrmacht actually required for operations. German fuel allocation by June of 1944 revealed the desperation pervading military planning. A Panther tank battalion, considered an elite armoured unit, received 300 gallons for an entire day's operations. This allocation had to cover combat manoeuvring, tactical positioning, and potential retreat movements. Crews received instructions to shut off engines whenever possible, to coast downhill to conserve fuel, to avoid unnecessary movement of any kind. Tank commanders spent more time calculating fuel consumption than planning actual combat tactics. Meanwhile, an equivalent American armoured unit received 30,000 gallons daily as standard allocation, and often received additional fuel upon request without questions asked. The Luftwaffe's situation was even more critical and desperate. On D-Day itself, June 6, 1944, the once mighty German Air Force managed only 319 sorties along the entire invasion front stretching across Normandy. The Allies flew 14,600 sorties that same day. Each German sortie represented careful fuel calculation and difficult choices, with pilots receiving instructions to avoid unnecessary manoeuvring to conserve precious fuel. American and British pilots, by stark contrast, flew multiple missions daily, conducted extensive training flights, and never considered fuel availability when planning their tactical maneuvers. The first 7 attempts to lay operational Pluto pipelines across the Channel failed spectacularly, ironically reinforcing German assumptions about technical impossibility. On August 12, 1944, HMS Latimer began laying a HAIS cable from Sandown on the Isle of Wight toward Cherbourg. The operation proceeded smoothly for 10 hours, with the pipeline unspooling perfectly as the ship moved at precisely calculated speed across the Channel. Then disaster intervened. An escort destroyer, manoeuvring to avoid what its captain believed was a submarine periscope, dropped anchor directly onto the cable, severing it completely. 2 days later, HMS Sancroft attempted another crossing. This time the pipeline was successfully laid across the entire distance, but as the ship manoeuvred to make the shore connection, the cable became entangled in HMS Algerian's propeller, destroying both the pipeline and damaging the escort vessel's propulsion system severely. Further attempts in late August failed due to different unforeseen problems. Barnacles had accumulated on the submerged portions of the massive conundrums, preventing them from rotating properly and causing the pipeline to jam during deployment. Another pipeline broke when it encountered an unexpected rocky outcropping on the seabed that hadn't appeared on available charts. German coastal observers, stationed in concrete bunkers along the Normandy coast, reported these activities to intelligence headquarters with dismissive commentary. A report from the 15th Army dated August 28 stated that enemy naval units were conducting repeated failed operations off Cherbourg with purposes unknown but results clearly unsuccessful. Multiple vessels were observed recovering equipment from the water. The assessment concluded these were failed attempts at minefield clearance or salvage operations, with no threat to defensive positions identified. Even more revealing was a Kriegsmarine intelligence assessment dated September 5. Allied naval activity in the Channel appeared consistent with attempted cable-laying operations, possibly for communications purposes. Multiple failures had been observed. Weather and current conditions made successful cable-laying highly improbable. The recommendation was to continue monitoring but assign low priority to the matter. The breakthrough came on September 22 when the first HAIS pipeline from Cherbourg to the Isle of Wight became fully operational, delivering those crucial 56,000 imperial gallons daily that would begin transforming Allied logistics. The pipeline had been laid successfully by HMS Conundrum 2 in a near-perfect operation, with weather conditions ideal and all equipment functioning flawlessly for once. 9 days later, on September 29th, HMS Conundrum 2 successfully laid a Hamel pipeline, adding another 70,000 gallons to daily capacity. By October 10th, when HMS Sancroft successfully laid a pipeline from Dungeness to Boulogne in just 5 hours, the system was delivering hundreds of thousands of gallons daily. This operation was particularly significant because it demonstrated that pipeline laying had transitioned from experimental to routine. What had seemed impossible in August was now accomplished in less time than conducting a standard naval patrol. Eventually, 17 pipelines would cross the Channel, 11 HAIS lines and 6 HAMEL lines, creating an underwater network of steel arteries feeding the Allied advance into Europe. German discovery of Pluto's existence came gradually and proved psychologically traumatic in ways that battlefield defeats never achieved. In late September, Wehrmacht engineers examining captured Allied fuel depots near Boulogne discovered something that defied all logical explanation. The depot contained massive fuel terminals with no visible supply source whatsoever. There were no storage tanks of significant size, no harbour facilities suitable for tankers, no rail connections, yet thousands of gallons flowed continuously into distribution points supplying forward units. Major Hans Dietrich, a petroleum engineer from IG Farben who had designed synthetic fuel plants before being conscripted into the Wehrmacht's supply corps, was assigned to investigate this mystery. His October 15th report to the Oberkommando der Wehrmacht, discovered in the Bundesarchiv Militärarchiv after the war, reveals the growing German awareness and bewilderment. "The enemy is receiving fuel through means we cannot identify," he wrote. Flow rates suggest pipeline delivery of approximately 800 tons daily at this location alone. Interrogation of captured American and British personnel yields consistent claims of underwater pipelines from England, which our engineers initially deemed technically impossible. However, physical evidence contradicts our assumptions. The fuel continues to flow from connection points that emerge from the channel itself. His recommendation was urgent technical investigation required. The psychological impact on German forces proved immediate and devastating to morale. Panzer crews who had been trained at the armour school at Putlos to conserve every single drop of fuel, who had practiced shutting off engines while coasting downhill, who calculated fuel consumption against tactical necessity with obsessive precision, now watched American tank crews leave engines running continuously even when stationary. Tank commanders reported American armour units conducting training exercises that consumed more fuel than entire German combat operations. A captured diary from an unnamed soldier in the 12th SS Panzer Division, dated October 19, 1944, provides intimate insight into the German reaction. He wrote of watching American Shermans practicing maneuvers for 3 hours continuously near Aachen. They burned more fuel in this training than we receive for a week of combat, he noted. He approached their supply sergeant during a temporary ceasefire to collect wounded and asked about fuel allocation. The American laughed and said they never measured it, just radioed for more when tanks ran low. "How do you fight an enemy that doesn't count?" the German soldier asked despairingly. The full scope of Allied fuel logistics became undeniable during Operation Queen, the November offensive toward the Roer River. German intelligence, through careful observation and analysis of captured documents, calculated that American forces in this single sector alone were consuming 1.2 million gallons daily. This single offensive was burning more fuel than the entire Wehrmacht Western Front received in a month. The Ninth Army's planned counterattack was cancelled when fuel allocation permitted only 4 hours of operations for the assembled armour. Meanwhile, American artillery fired continuous barrages for 72 hours straight, with each shell delivered by fuel-consuming trucks in endless convoys that never seemed to diminish in number or frequency. General der Panzertruppen Hasso von Manteuffel, one of Germany's most capable armour commanders, who had distinguished himself repeatedly on the Eastern Front, reported to Hitler on November 20th from his 5th Panzer Army headquarters. "The enemy possesses unlimited mechanical movement," he wrote. "They conduct reconnaissance with vehicles where we must use foot patrols to save fuel. Their artillery moves frequently to avoid counter-battery fire, while ours remains static because we lack fuel to relocate guns. Our tactical superiority becomes meaningless when they can sustain operations indefinitely while we measure movement in litres. This is not a disadvantage that leadership or will can overcome. This represents material superiority that renders traditional military skill irrelevant." Hitler's response, recorded in the Oberkommando der Wehrmacht War Diary, was predictable but revealing of his disconnection from reality. He raged against defeatist generals and ordered increased production through will and national spirit. He commanded Albert Speer to double synthetic fuel production within 30 days, a demand that Speer knew was physically impossible. The synthetic fuel plants at Leuna, Bohlen, Pölitz and Brooks were operating at barely 20% capacity when not completely shut down by bombing raids. The October production of 17,000 tons was achieved only by cannibalizing equipment from damaged facilities to keep others running. This monthly production represented what Pluto would soon deliver in less than 4 days through its underwater pipelines. The Battle of the Bulge in December 1944 exposed the fatal consequences of Germany's fuel poverty versus Allied abundance in the starkest possible terms. The entire Ardennes offensive, Germany's last major operation in the West, depended fundamentally on capturing American fuel dumps intact and using captured fuel to continue operations. The operational plan, personally approved by Hitler during detailed planning sessions, explicitly stated that after Day 3, advancing units would operate on captured enemy fuel. This wasn't optimistic planning or hoping for the best, but desperate necessity born from mathematical reality that couldn't be avoided or minimized. The numbers were absolutely merciless. The assembled German forces for the offensive included 6 Panzer divisions, 5 Panzer Grenadier divisions, and 18 Volksgrenadier divisions. These forces required approximately 2 million gallons of fuel to reach Antwerp, their ultimate strategic objective. They possessed less than 400,000 gallons at the offensive's start. The plan literally required capturing 5 times more fuel than they possessed, assuming no combat losses whatsoever, and perfect mechanical efficiency throughout. SS Obersturmbannführer Joachim Peiper's Kampfgruppe, spearheading the 6th Panzer Army's assault with 72 tanks, including the newest King Tigers, carried enough fuel for 30 miles of movement on roads. The operational plan required advancing 125 miles to the Meuse River. Peiper's force needed to capture American fuel supplies at Stavelot, Trois Ponts and Spa to continue advancing. When American engineers destroyed these dumps, some containing over 2 million gallons each, Peiper's elite force was immobilized within 72 hours of the offensive's start. The arithmetic of failure was brutally simple. A King Tiger tank consumed 280 gallons per 100 miles on roads under ideal conditions, often over 500 gallons in actual combat conditions involving maneuvering and fighting. Piper's battalion of King Tigers alone needed 50,000 gallons to reach the Meuse River. They had less than 8,000 gallons available. The finest heavy tank unit in the German military was reduced to abandoning their vehicles and walking back to German lines through the Ardennes forest in bitter winter weather, leaving their tanks as monuments to failed planning. Meanwhile, the American Red Ball Express truck convoys were delivering 400,000 gallons daily to units opposing the German offensive. The contrast was captured by an American quartermaster officer who reported that German prisoners kept asking where all the American fuel came from. When told about pipelines under the ocean and truck convoys running 24 hours continuously, they refused to believe it. One German officer said it was physically impossible. The American showed him their daily fuel receipt, documenting 300,000 gallons delivered that morning alone. The German officer broke down crying. By January 1945, German intelligence had finally confirmed the impossible reality of Operation Pluto through captured technical documents and systematic interrogation of Allied prisoners who had worked on the system. The specifications stunned Wehrmacht engineers who had considered themselves masters of military technology. The pumping stations at Dungeness and the Isle of Wight employed Byron-Jackson centrifugal pumps manufactured in California and shipped to England, each capable of generating 1,500 pounds per square inch of pressure. These stations could deliver 3,500 tons daily through a single pipeline, a capacity that exceeded anything in German industrial experience. The pipeline construction itself represented engineering that surpassed German capabilities across multiple dimensions. The HAIS cable's lead pipe core was manufactured to tolerances that exceeded German submarine battery cases, crucial components that received the highest manufacturing priority. The steel tape wrapping was stronger than the armor plate used on German tanks, yet remained flexible enough to coil around drums. The armoured wire protection surpassed anything in German cable manufacturing, using special alloys that Germany couldn't produce in quantity, even if they had known the formulas. Most devastating to German pride was discovering this represented standard Allied engineering, not miracle technology or revolutionary breakthrough. The pumps were commercial models adapted for military use rather than custom-designed equipment. The pipeline materials were manufactured by civilian companies using existing industrial processes scaled up. The laying techniques were adapted from submarine cable operations that had been routine since the 19th century. The Allies had solved the impossible problem through sheer industrial capacity and engineering competence, not through any revolutionary scientific breakthrough. Professor Ferdinand Porsche, designer of the Tiger tank and one of Germany's most celebrated engineers, was shown captured Pluto documentation in February 1945. His analysis, found in his personal papers donated to the Porsche Museum, was devastating to German technical pride. The steel required for 1 mile of their pipeline exceeds our monthly allocation for all military vehicles combined, he wrote. They have laid 500 miles. The lead in their pipes exceeds our submarine battery production for 6 months. They use it for fuel transport. The pumps each exceed our largest industrial units in both capacity and pressure. They have dozens operating continuously. This is not a technological advantage we can overcome through effort. It represents technological dominance from a fundamentally superior industrial civilization. The human dimension of this disparity created countless individual tragedies that illustrated the larger catastrophe consuming Germany. Wehrmacht medical units reported in January 1945 that they were abandoning wounded soldiers because ambulances lacked fuel for evacuation to hospitals. Units were forced to choose between using their last fuel to retreat and survive or to evacuate casualties. Most chose retreat, leaving wounded comrades to become prisoners, a choice that haunted survivors for decades. Meanwhile, American forces flew medical evacuation missions using light aircraft, with each flight burning more fuel than a German field hospital received monthly for all purposes. German soldiers froze in winter defensive positions without fuel for heating, while American troops complained in letters home about excessive warmth from gasoline-powered tent heaters that ran continuously day and night. Letters from German soldiers captured in early 1945 reveal the complete psychological collapse caused by this fuel disparity. A Fallschirmjäger sergeant wrote to his wife in a letter that was never sent because he was captured first. "The Americans wash their jeeps daily with heated water," he wrote. "They run engines to charge radio batteries while we have no batteries at all. They burn gasoline to heat coffee, to warm food, to dry clothes. We haven't seen fuel for our vehicles in 2 weeks. This isn't war anymore. It's industrial extermination by an enemy who has everything while we have nothing." Albert Speer, visiting the Western Front in January 1945 on Hitler's direct orders to assess the situation firsthand, witnessed the futility personally. In his post-war memoirs titled Inside the Third Reich, he recalled watching American vehicles streaming endlessly toward the front, each burning fuel that would have supplied a German company for a week. When he learned they were pumping this fuel from England through underwater pipelines, he knew the war was not just lost, but had been lost from the moment Germany failed to understand what kind of enemy they faced. Germany had prepared for war against nations like themselves with similar limitations, he realized. They faced instead an industrial colossus that could perform engineering miracles as routine operations. The technical details of Pluto, when fully revealed through post-war analysis, showed the true chasm between Allied and German industrial capacity at every level. By March 1945, 17 pipelines crossed the Channel, creating over 500 miles of underwater steel highways carrying petroleum. The system employed approximately 1,000 specialist personnel operating in 3 shifts around the clock to maintain operations. Over 100 pumping stations, from major facilities to small booster stations, maintained pressure throughout the network. The Dumbo section from Dungeness to Boulogne alone consisted of 4 3-inch HAIS cables and 7 HAMEL pipes, capable of delivering 8 100,000 gallons daily. The lines were laid in depths ranging from 60 to 180 feet, crossing shipping channels, tidal races, and rocky outcroppings. The engineering required to maintain consistent pressure while accounting for depth changes, temperature variations, and tidal movements exceeded anything in German industrial experience or capability. The redundancy built into Pluto particularly amazed German engineers studying the captured documentation. Multiple pipelines meant that mechanical failures, always expected in such complex systems, never stopped fuel flow to combat units. When winter storms in December 1944 damaged 3 pipelines simultaneously, the system continued delivering 800,000 gallons daily through the remaining operational lines. Repair crews fixed the damaged sections within 96 hours, while operations continued uninterrupted. This philosophy of building excess capacity as insurance rather than waste was incomprehensible to German planners accustomed to perpetual scarcity. German military doctrine emphasized concentration of force and using every available resource at the critical point. The concept of maintaining reserve capacity, of building redundancy into systems, of accepting inefficiency for reliability, was foreign to minds shaped by perpetual shortage. German attempts to interdict Pluto came too late and proved pathetically inadequate against such a distributed system. In January 1945, the Luftwaffe's few remaining bombers attempted to attack pumping stations at Dungeness and Shanklin Chine on the Isle of Wight. The raids required careful planning and consumed precious fuel that could have supported ground operations for days. 43 bombers took off for the mission. 11 were shot down by fighters, 7 by anti-aircraft fire, 6 turned back with mechanical problems. The surviving aircraft dropped their bombs on targets that proved to be camouflaged decoys. The actual pumping stations, dispersed and hardened, continued operating without any interruption whatsoever. The Kriegsmarine's efforts were even more futile and demonstrated their complete impotence. Admiral Karl Dönitz ordered his last operational U-boats to locate and attack the pipelines, but they lay invisible on the channel floor under tons of water and accumulated sediment. U-boat commanders reported that even if pipelines were somehow located, they possessed no weapons capable of damaging them at such depths. The submarines themselves operated on such critically limited fuel that some attempted patrols with only enough diesel to return to port if they proceeded at minimum speed and avoided all combat encounters. The war log of U-873, captured when the submarine surrendered in May 1945, recorded the futility perfectly. Ordered to locate and destroy enemy fuel pipelines in channel, it stated. Searched for 7 days using passive sonar and visual observation. Found nothing. Fuel state critical. Batteries failing. Forced to return having accomplished nothing. The pipelines remain invisible, invulnerable, incomprehensible. By February 1945, Allied engineers were preparing to extend pipelines across the Rhine River directly into Germany itself. German commanders realized with horror that the Allies could theoretically run pipelines anywhere their armies advanced, bridging any obstacle. The Rhine, Germany's last major natural barrier, could be bridged underwater as easily as the Channel had been. This prospect represented the ultimate defeat in German minds, facing an enemy that could project not just military force but industrial infrastructure itself across any distance, over any obstacle, under any conditions imaginable. The numbers told the final story with mathematical brutality that no amount of propaganda could obscure or minimize. Between September 1944 and May 1945, Operation Pluto delivered 172 million gallons of fuel to Allied forces in Europe. The entire German fuel production for 1944, combining military and civilian together, totaled 23 million gallons. The Allies pumped more fuel through undersea pipelines in 2 months than Germany produced across its entire territory for the entire year. Post-war analysis revealed additional ironies that deepened German humiliation even further. Pluto had experienced numerous technical problems and never achieved its designed capacity. The first operational pipeline didn't function until September 22nd, 3.5 months after D-Day, when the invasion was already well established. The system delivered only 8% of total Allied fuel needs, with the remainder coming from conventional tanker delivery and the Red Ball Express truck convoys operating continuously. Yet even this flawed, partially successful system exceeded Germany's entire fuel infrastructure in every measurable category. General Heinz Guderian, creator of Blitzkrieg doctrine and Germany's foremost expert on armoured warfare, provided perhaps the most perceptive analysis in his post-war memoirs. "We invented modern armoured warfare," he acknowledged. "We showed the world how to use tanks, aircraft and infantry in devastating coordination. We developed the tactics, the communications, the doctrine that every army subsequently copied. But we never solved the fundamental problem of how to fuel such operations continuously over extended campaigns. The Americans and British didn't invent armoured warfare. They invented something more important, the ability to sustain it indefinitely. We won battles. They won the war." Field Marshal Gerd von Rundstedt, reflecting on his defeat as Commander-in-Chief West, stated during his interrogation at Bad Mondorf that Allied Pluto pipelines were not their greatest achievement. Their greatest achievement was considering such pipelines normal, merely another engineering problem to solve like any other. "We Germans prided ourselves on technical excellence, on engineering precision, on scientific advancement," he said. "But we thought small, tactically. You thought strategically, industrially. You didn't defeat our army. You defeated our entire conception of warfare." The psychological impact extended far beyond immediate military implications. German soldiers who had maintained faith in ultimate victory despite retreats and relentless bombing now understood they faced an enemy with apparently unlimited industrial capacity. If the Allies could build pipelines under the ocean while simultaneously producing 300,000 aircraft, 88,000 tanks, and millions of vehicles, what possible hope existed for Germany? The revelation of Pluto shattered not just military morale, but the entire ideological structure of supposed Nazi superiority. A captured SS officer's letter from March 1945, found in Allied intelligence files, summarized the despair-consuming German forces. "We were told German engineering was supreme, that German science led the world," he wrote. "Yet they build underwater pipelines while we cannot maintain rail lines under bombing. We were told our will would triumph over material disadvantage, but will cannot create fuel from nothing, and they have everything while we have nothing." The discovery of Pluto's existence spread through German ranks like psychological poison, destroying morale. Wehrmacht propaganda had assured soldiers for years of German technical superiority, of the inherent weakness of democratic nations, of the inevitable triumph of authoritarian efficiency over democratic chaos and disorder. The revelation that the Allies had accomplished something German engineers deemed impossible while considering it routine work shattered this mythology completely and irreparably. General Wilhelm Keitel, chief of the Wehrmacht High Command, received reports of collapsing morale directly attributed to Pluto's psychological impact. One report from the 7th Army dated March 10, 1945, noted that knowledge of enemy fuel pipelines under the ocean had convinced troops that American industrial capacity exceeded all propaganda claims by enormous margins. Soldiers openly questioned what other impossible capabilities the enemy possessed. Requests for fuel were met with bitter laughter. Tank crews refused to advance, knowing their vehicles would be abandoned within hours for lack of fuel. The last German military assessment of Pluto came from Field Marshal Albert Kesselring in April 1945. His report to Hitler, one of the final strategic assessments of the war, stated that the enemy had industrialized logistics itself. "They do not transport fuel," he wrote. "They pipeline it across ocean floors. They do not worry about consumption. They assume unlimited supply. They do not calculate fuel for operations. They simply conduct operations assuming fuel will flow. This represents a form of warfare we never conceived and cannot counter with available resources. We are fighting the past war while they are fighting the future one." Pluto's legacy extended far beyond the war's immediate end. German military professionals studying at NATO staff colleges in the 1950s focused obsessively on logistics and supply chain management, traumatized by watching enemies with unlimited fuel defeat forces possessing superior tactics and weapons. The Bundeswehr, established in 1955, emphasized logistics and sustainability over tactical brilliance as its founding principle. Every German military operation since has been planned with fuel supply as the primary consideration, not a secondary concern to be addressed after tactical planning. Hans Speidel, Rommel's former chief of staff, who later became NATO commander of Allied land forces Central Europe, wrote in 1960 that Pluto taught Germany that modern war is won in factories and engineering offices, not on battlefields. "The side that can sustain operations longest prevails," he wrote. "The side that can transform industrial capacity into military capability most efficiently wins. We learned this lesson at the cost of our nation's destruction. We will never forget it." The 17 pipelines of Pluto were decommissioned in 1946, with recovery operations beginning in September of that year. The salvage effort itself demonstrated Allied industrial efficiency even in peacetime. Using the same ships that had laid the pipelines, now renamed for civilian service, crews recovered over 22,000 tons of steel and lead, materials desperately needed for post-war reconstruction. The operation took less time than the original installation, despite operating with reduced crews and aging equipment. The system's true legacy proved to be the complete transformation of military logistics thinking worldwide. For German officers who had dismissed supply as a mere support function secondary to operations and tactics, Pluto delivered brutal education that would reshape military doctrine globally for generations. Logistics was strategy. Industrial capacity was military power. The ability to sustain operations indefinitely was more important than tactical brilliance or individual courage. The story of German forces discovering Operation Pluto ultimately reveals the collision of two incompatible concepts of warfare. Germany had perfected traditional military excellence through professional officers trained at the Kriegsakademie. Superior tactics developed through careful historical study, advanced weapons like the Tiger and Panther tanks, and disciplined soldiers indoctrinated from youth in military values. The Allies had industrialized warfare itself, transforming it into applied industrial capacity, where victory went not to the best soldiers, but to the best production and distribution systems. In the final analysis, Pluto's 172 million gallons represented far more than petroleum products. Each gallon was proof of Allied industrial supremacy, flowing through steel arteries laid on the ocean floor by nations that had mobilized their entire productive capacity for victory. The German military machine, for all its tactical brilliance demonstrated in France, Poland, and Russia, for all its technical innovation in tanks, rockets, and jets, for all the courage of its soldiers fighting to the bitter end, was defeated by pipelines it couldn't imagine carrying fuel it couldn't match from an enemy whose industrial power exceeded not just German resources, but German comprehension. The last documented German reaction to Pluto came from an unknown Wehrmacht colonel whose interrogation transcript was found in the United States National Archives. Asked why Germany lost the war, he responded simply, "You could pump fuel from England to France under the ocean. We couldn't pump fuel from Berlin to Hamburg over land. You had already won the war before the first shot was fired. We just didn't know it yet. We brought a knife to a gunfight, but worse, you brought a factory to manufacture unlimited guns." Operation Pluto stands throughout history as the supreme example of logistics as strategy determining war's outcome. While German forces counted litres and calculated kilometres, while tank crews siphoned fuel from disabled vehicles and commanders cancelled operations for lack of fuel, Allied forces pumped unlimited petroleum through underwater pipelines, turning the English Channel from a protective barrier into a highway for the fuel that would power victory. The German discovery of this reality marked not just military defeat, but the complete collapse of everything they had believed about warfare, technology, and their own superiority. The Third Reich, which had promised thousand-year dominance through racial superiority and will, was defeated by superior plumbing, by engineers who could lay pipes on the ocean floor, by workers who could manufacture pumps and pipelines faster than Germany could produce rifles. The pipelines kept pumping until May 1945, continuing for 5 days after Germany's surrender on May 8th, a final symbol of Allied industrial momentum that could not be stopped even by peace itself. German engineers, now prisoners of war, were sometimes employed in dismantling the very system they had never believed possible. As they worked, many reflected on the elegant simplicity of what had seemed impossible. Steel tubes on the ocean floor carrying the fuel that had powered their defeat. One German engineer, whose name is lost to history, reportedly said while working on pipeline recovery operations that Germany designed Tigers and Panthers, the finest tanks ever built. The Allies designed pipelines to fuel Shermans forever. Which was really the superior engineering, he asked rhetorically. In the end, Germany's finest military minds learned the hardest lesson of modern warfare, that courage, skill, and superior weapons mean absolutely nothing without the fuel to operate them continuously over sustained campaigns. The Allies had solved this equation with pipelines under the ocean, with pumps that never stopped running, and with the industrial capacity to build redundancy into everything they created. Germany never solved it at all, fighting to the very end with horse-drawn transport operating alongside Tiger tanks, with Messerschmitt 262 jets grounded for lack of fuel while inferior Allied aircraft flew continuously. That difference, more than any battle or campaign, more than any general's brilliance or soldier's courage, more than any tactical innovation or strategic concept, determined the war's outcome. The 17 pipelines of Pluto delivered victory 1 gallon at a time, flowing from England to France through steel arteries laid on the ocean floor, unstoppable as the tide itself, carrying not just petroleum, but the industrial might of democratic nations mobilized for total war. Against this force, the Wehrmacht's tactical excellence and advanced weapons proved as futile as swords against machine guns. German troops who had dismissed logistics as secondary to operations learned too late that in industrial warfare, logistics was everything. The side that could sustain operations longest would win. The side that could transform industrial capacity into military capability would triumph. The side that could pump fuel under oceans while the enemy counted litres had already won before the first battle was fought. The story of Pluto is ultimately the story of how the Second World War was actually won, not through brilliant strategy or superior tactics, not through courage or advanced weapons, but through the mundane ability to deliver fuel continuously to machines that consumed it voraciously. The Allies understood this fundamental reality. Germany never did, and in that failure of imagination lay the seeds of the Third Reich's destruction, defeated not by armies but by pipelines, not by generals but by engineers, not on battlefields but on the ocean floor where steel tubes carried the fuel that powered victory and changed warfare forever.